Hello everyone, I'm Dad. I'm the first author of this work, which is named VSC Visual Search Compositional Text to Image Diffusion Models. So let's go to it. First of all, we observe a phenomenon which is like the current text to image diffusion model. They cannot generate faithfully when the prompt having two or more attribute binding object prompt. So for example, given a prompt like a red car and a yellow bicycle, the diffusion model generates this image, which is just a car with a combination of yellow and red. So we want to ensure the accuracy of this. And to do that, we individually retrieve the visual information, which is like generate the reference image for each pair in the prompt, and we use those reference image to generate the final compositional image according to the prompt. Mm, So we need to create a data set to train the model on this. So from T2I Combench dataset, which is a dataset of compositional prompt, and for each prompt, we generate 30 image and select the image with the best belief VQA and clip score. So, for example, given these two images, the belief VQA will try to do the visual question answering. For example, like, is there any wooden table in this image, or is there any leather chair in this image? So, and for the clip score, we want each object to be represented fully in the image. So we also extract the mask of the image of the object, and then we evaluate clip individually on the object only. Yeah, so finally, the final dataset we training on is consists of 90,000 image. For the training pipeline, after generate the reference image, the blue apple and the green backpack, we feed it into an image encoder, and to get the visual embeddings, and we concat it with the original text embedding and going through an MLP to get the final embedding with the correct dimension. And that embedding will go through the diffusion model again to predict to get the final image. And throughout the training, we only tune an MLP and the last two or three layer of the encoder. So the training is very fast, and we can run it on like just a single GPUs. So for the result, we also use the blip VQA as a metric and VSC across three versions of stable diffusion. We outperform the all of the prior work, and and notably, like most of the no, previous work, they are inference time method, which is they optimize on inference. And for the quantitative result, you can see that our VSC produce a better image in the visual quality. We also do human evaluation on this one, and the majority of people also agree with us. Finally, we observe some amazing property that VSC has. So first of all, as the number of binding pairs in the prompt grow, most of the prior work, they do inference optimization. So the runtime also increase linearly with the number of pairs. And we see, because we generate the reference image in parallel, so our inference cost is quite stable. And as we grow, the VSC will be faster and remain this accuracy. Secondly, we see the transferable compositionality, which is like when we only train the VSC on the color only image dataset, we see the improvement in the other categories such as texture and shape. So this implies that the VSC can also generate a better binding image on the other category beyond the one that they are trained on. So, and finally, we see the scalable training, and as we scale up the dataset size, the accuracies also scale up, implies that VSC can be further improved by just providing more data, maybe real data or just the number of data, synthetic data. Thank you for listening.